So this is problem 1, intro to kinetics, and it's about the mass moment of inertia of a pendulum that have two thin rods. So it's composite body with have two thin rods, each weight 10 pounds, and compute this pendulum mass moment of inertia about an axis passing through, in this case perpendicular to the screen, through O there and to the center of mass of the pendulum G, which is locate y bar from O. So we need to find the y bar, which is located where is the center of mass of this composite body. So a few things we need to do before we go to make a table from the section 12 of the reference data card. If you recall, the weight equal to mg. So from that we can have the mass equal to weight divided by g, and in this case the g equal to 32.2 feet per second, so 10 divided by 32.2. From that we can have 10 divided by 32.2 equal to 0.3106, and the unit should be slug, because the G is 32.2 slug per feet square. And for the pendulum, keep that in mind, have two rods, so that is about the thin rod. If you go to the inside cover of the textbook that we refer in the lesson, there are different standard shape, in this case the thin rod. So there are a few mass moment of inertia, but if they go through the center G that I circle in there, so it means the x-axis or y-axis, the mass moment of inertia equal to 1/12 of ml squared if they go through the center of the rod. If they go to the x bar, x apostrophe or y apostrophe, which is very end of the rod, then it will be 1/3 of ml squared. You can see there. So it depends on where you locate the axis that you calculate the mass moment of inertia. The equation are not the same. So let's talk about the x-axis or y-axis where they go through G and perpendicular to the rod, which is ix I y 112 ml squared. So write down here so that we don't have to go back there. So we have I go to the GI of each standard rod equal to 112 ml squared, where you L basically the length of the rod. So with that, we can make the table. Go to the reference data card, section 12. This is the table, and similar to find out the centroid, basically this section is to find out the centroid, or in this case it replaced with the areas. If here the mass, so we find out the center of mass. So we may first find out the center of mass first for that. And the fourth, this column, basically to find out the x bar of the standard shape, where location of the center of mass. This case, luckily, the body is homogeneous and it perpendicular, symmetrical to the y-axis. With that, and you can see the G have to be located on y, and with that x bar equal to 0. So let me call the two axes y, in this case a little bit strain going down, and x as usual go to the right, and then you see x bar will be 0. So let's first find out the center of mass. So let's find out center of mass. So then make a simple table which including the shape. We have the shape, and then we have the y bar, because we don't need x bar. You already know 0 for each standard shape, and then we have the mass for each standard shape, and we also the products of y bar I times the mass of each standard shape. Okay, so mass here we call that mi, right? Mi there, and from that we can make a table just only purpose to find out uh, the centroid, the center of mass in this problem. So the first table we make. So this is a composite body. We have to break it down into two. The first is the vertical rod that we highlight here from O to the point there, and then the horizontal rod BC. That's the two shape that we want to draw on the shape here. So let's draw that two. We have the one vertical, and let's call that a G1, and then the one horizontal with the length of G2. The length of the first one is 1.8, as you can see there. This is 1.8 feet, and G2 basically equal to 2 feet. So that's the table we have for the first one. So go ahead to fill out y bar divided by from the center, the coordinate origin O to the centroid, to the center of mass of the standard shape. So the one in the middle here, that is the center of mass of the standard shape vertical thin rod. And then the center of mass of the horizontal shape, it will be there, G2 in the center. So the distance from O to G1, that will be y bar I. In that case, as you can see, the total length is 1.8 feet. So O to G1, it will be 0.9. So let's write down. Basically, that is O to G1. So that will be 0.9. Let's put that in feet unit there. Okay. Similarly, the one in from the shape horizontal G2 to O. So G2 to O, as you can see, they divide that 2 feet. So that will be y bar E O to G2. So from the point that you want to locate y bar to the center of mass for each standard shape on your left. So it will be 2 feet. The mass each have 10 pounds. So mass is have to divide by G. So let's talk about each of them. The same. So you have 10 pounds. 10 pounds. Divide by G. You can put the number in. What is the number in there? You can see here, right? 0.3106 slugs. But here make life easy. We just put the divide by the gravitational acceleration. And the products of this 2.9 times 10 over G, we will have 9 and G very confused for my handwriting. 9 divided by G. And this one, 2 times 10, so it's 20 divided by G. So with that, the y bar, as you can see, similar to y bar in the centroid that we learned earlier. So we have y bar equal to sum of all the yi, mi divided by sum of all the mass. So plug in, we have 9 over G plus 20 over G. So you have it 29 over G. Divided by m, it will be each 10 over G plus 10 over G, so it's 20 over G. G cancel out, so it will be 1.45, 29 divided by 20 feet. And that basically the location of the centroid of the composite shape in here, y bar equal to 1.45